Okay, what I'm going to try and do today is explain to you how a governor on a small engine works. There's a few videos getting around, none that I've seen that I'd be totally happy with on how they work, so I thought I'd make up my own. Because the ones I've seen, they sort of, there's a few gaps they don't fill in, so I thought I'd make my own up and see if that is a bit better. I'll have to apologise for the quality. It's just on a handheld phone, and this is the first one of these I've ever done. So please be patient. I'm sure you get a bit out of it. One of the things I'm going to talk about is why we'd have a governor. We have a governor on an engine for, I don't know how many reasons, but they seem to be only on smaller engines. We don't have a governor on a car or a motorbike because as we're driving the car or the motorbike ourselves, we can adjust the throttle as required. So if you're driving along in a car at 100 kilometers an hour and you encounter a hill, you'll still maintain a consistent road speed of 100, but you will apply more throttle to compensate for the extra load, and that will maintain the speed. And when you get to the top of the hill or over the hill, you'll back off the throttle to just maintain that engine speed, because you don't need as much throttle application. On a small engine, we don't want that worry. Maybe on a lawnmower, we don't have them because we're too busy admiring how good our lawn looks to be worrying about throttle control. So the thing with a small engine, whether it's on a push mower, ride-on mower, pump generator, once the throttle, the engine speed has been set, the governor just takes care of everything when the engine encounters a load. So when you're mowing the lawn, the load might be a thicker patch of grass. You may even be mowing up a hill. So the governor takes care of the extra throttle. So first of all, the parts of the governor. This is a Honda engine here, and this bit here, throttle butterfly. So that's in the idle position, that's in the full throttle position. Okay, full throttle, full noise, full fuel, full air. There's a linkage that goes back here to an arm. This arm, great. This arm down the side here comes in as attached to a shaft at the bottom, and there's a spring here. And the interesting thing about it is, and there's our throttle actuator. Okay, so throttle butterfly up here, and there's our actual throttle. And you'll notice that when you operate the throttle, it goes through a spring and then through the arm and then the rod to the throttle butterfly. So there's no direct mechanical link between the throttle and the throttle actuator and the butterfly. It's through a spring and levers. And in the idle position, in the idle position, that's actually quite loose, and I can just easily take that spring off there. I'll just sit that back on. That wouldn't normally happen. I think one of the adjustments might be out on this engine. Can I get that spring off? There we go. Okay, the internals. There's a few different types of governors. I'll just explain this mechanical one here. This is a Honda engine, but just up here I have a part. The Honda works the same, but this one we're looking at here on the wall is a Briggs engine. Internally, there'll be a setup like this, where we've got a gear that turns, and we've got some weights, and those weights are attached to a rod here, that when this turns, the weights spread sideways just with inertia, and just through the lever action of those weights, it pushes the rod forward. That rod pushes forward and actuates on a lever, this lever here, great, which is the same as this lever here. But all we've got to worry about for now is when the motor's spinning, the weights are actuating on this lever. This particular engine here, this is a Briggs lawnmower, and instead of weights, it's actually got a vane here. It actually works off wind. We've got these vanes on the flywheel which help cool the engine, but also the wind, as it's coming off the flywheel, operates this vane, and this vane works in the same way that this lever does. Okay, this lever's got weights actuating on it. This lever has wind. Okay, so, but they work exactly the same. This type can be adjusted. As far as I know, this type can't be adjusted. Why would you want to do it anyway? They work fine. Okay, how the governor actually works. So I think these engines sort of run at about 3.5 or 3,700 RPM. Say you set the RPM at 2,000. You just want to run the engine, do its work at 2,000 or 2.5. So you operate the throttle at 2.5, to the position that would give you 2,500 RPM. Whether you do that by the sound, just with your ear, or just by a tacho. Anyway, the engine speed is set at 2,500 RPM. What is actually happening is that gear is spinning, those weights are spread out, that rod is being pushed forward, and that is applying a load on this lever. Okay, what the weights want to do, the weights actually want to close the throttle. All they want to do through how they mechanically work and the action of the weights is close the throttle. So if the weights were allowed to do what they just wanted to do, the throttle would be closed. But what we've got here is a spring. And if the spring was able to do what it wanted to do, it would go to full throttle. So what actually happens is the weights, the inertia of the weights and the rod and this lever and the spring, they come to a point of equilibrium. They agree on a certain position, so they're happy. So that happy position might be about 2,000 to 2,500 RPM, whatever you've got it set to. Okay, so that's one thing that's got to be understood. What actually happens then is the motor will run quite smoothly. But when we encounter a load, that's when the governor, that's when the fact that we've got a governor takes over. If you ran the motor all day at 2,000 RPM and it didn't encounter a load, the governor wouldn't be doing that much. But how the governor works its magic, I'm about to explain. So what happens, so picture the engine doing 2,000 RPM and it encounters a load. So this wants to shut the throttle, the spring wants to open the throttle, but they're in equilibrium. So what happens when the engine encounters a load? Momentarily, the engine will slow down. Just physically will slow down because it's set at a certain throttle position. That throttle position won't maintain the RPM. So momentarily, the weights, because the engine is slowing down, the action of the weights isn't as strong. So the lever will not have as much force. So momentarily, the spring will win. The spring that wants to open the throttle will be able to open the throttle more. So while the engine is going at a lower speed, the spring does its job and opens the throttle more to maintain the engine RPM. Once the load, if the engine is there going through the load for a period of time, the speed will equalise. But if the load is only there for a short time, the throttle position will change. You'll go through the load, and the other end of the load, because the throttle is in a higher position, the engine speed will momentarily rev up. What that will do is, because this is spinning faster, it will apply a bit of extra force, and that will mechanically close the throttle back to the original position. And all this is happening without the throttle even moving. It's the spring and the weights in behind here pushing on this lever that are constantly fighting against each other. Sometimes the weights win by slowing the engine down. Sometimes the spring wins by speeding the engine up. But they generally work in an equilibrium position. The spring tension equaling out the force of the weights. Hopefully that helps. Please post any questions. Thanks.